So decomposition helps us to remove the redundancy, inconsistency from the relational table. So while performing some basic operation, it leads to an inconsistency and redundancy. That is called anomaly. Here all employee name, salary and city depend on employee number. In maximal cover, every dependency on the left hand side should be a single attribute. Hello everyone, welcome to another session of DBMS. I am Soundarya from BCA department, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. So today let us see the third unit as per the Mysuru University, that is data normalization. So in data normalization, the first concept is anomalies. So in anomalies means the inconsistency or redundancy occur while performing some basic operations like insert, delete and update. So anomaly means inconsistency occurred in the relational table during the operations performed on the relational table. The operations may be insert, delete and update. So while performing some basic operation, it leads to an inconsistency and redundancy. That is called anomaly. There are three types of anomalies that is occurred when the data is not normalized. So these anomalies occurs when the data is not normalized. So normalized means there is no redundancy or inconsistency in the relational table. Suppose if there is any inconsistency and redundancy occur, that is leads to anomaly. There are three types. One is insert, update and delete anomaly. So let us see the one by one. In that, the first one is update anomaly. So in the update anomaly, when you want to update in the relational table, here we have a table called Ramesh. In that Ramesh table, you want to update Ramesh address. So here there are two Ramesh and you need to update all the table where the Ramesh is present. Suppose if you update only this table, that is leads to update anomaly. Now when you update some rows in the table and it leads to the inconsistency of the table, then this anomaly occurs. So this type of anomaly is known as update anomaly. As I told you, in update anomaly, if you want to update only the address of the Ramesh and other column has to update, that is leads to update anomaly. Next is insert anomaly. In insert anomaly, if there is new row inserted in the table and it creates the inconsistency in the table, then it is called insert anomaly. Suppose if you want to insert a new element into the table and it's not accepting, that leads to an insertion anomaly. Next is deletion anomaly. In deletion anomaly, if you want to delete one particular row from the table and all the attributes present in the table, that will got deleted, that is leads to deletion anomaly. If you delete some rows from the table and if any other information or data which is required, that is also deleted from the database, that is called deletion anomaly. So example for deletion anomaly, suppose if you want to delete the worker department of the Rakesh ECT 669 and the details of the Rakesh will also deleted, that is leads to deletion anomaly. Next is decomposition. So decomposition helps us to remove the inconsistency and redundancy from the relational table. It divides the single table into multiple tables. So the process of decomposition in DBMS help us to remove the redundancy, inconsistency and anomalies. So which are performing some basic operations like insert, delete and update. Decomposition help us to remove those redundancy and inconsistency from the database when we divide the table into numerous table. You can divide the table into multiple table, that is decomposition. The process of decomposition refers to dividing the relation table X into X1, X2 and Xn. Suppose you have a table X, you can divide that table into X1, X2 up to Xn. The decomposition in DBMS remove the redundancy, anomalies and inconsistency from the database by dividing the table into multiple tables. Next is types of decomposition. There are two types of decomposition. One is lossless decomposition and the second one is lossy decomposition. So the first one is lossless decomposition. The name itself says lossless, where the information or data are not lost. So in lossless decomposition is not lost from the relational table. The data or the information is not lost from the relational table and it is decomposed. Then the decomposition will be lossless. The lossless decomposition guarantees that the join of the relation will result in the same relation as it was decomposed. In lossless relational table, if you divide the table into multiple tables, it will join the table and return the data same as it is. So that will result in the same relation as it is decomposed. The relation is said to be lossless decomposition if the natural join of all the decomposition. Suppose if we want to say the relation is lossless, we use join operation to get back the original data and it is called decomposition. The example for lossless decomposition, here we have employee and department table. So in employee we have employee ID, employee name, employee age, employee city, department ID and department name. So when we divide that table, we get employee table. Here we have employee ID, employee name, employee age and employee city. So this is called lossless decomposition where the information are not lost. Next is lossy decomposition. In lossy decomposition, the name suggests when the relation is decomposed into two or more relations. So when the relation is decomposed into two or more relations, that means the table get divided into two or more table. The loss of information is unavoidable when the original relation is retrieved. Here we don't lose the information, but suppose if the information is lost, the original data will be retrieved. The example for that is employee information table. In that we have employee ID, employee name, employee age and employee location, department ID and department name. Suppose if we divide that whole table into two tables, we get two tables. One is employee details table and another one is department detail table. So in employee table we have employee ID, employee name, employee age and employee location. In department we have the details of department ID followed by the employee name. This is an example for lossy decomposition. Next is functional dependency. In functional dependency, it determines the relation of one attribute to the other attribute. Here we say that X. So X is a determinant and Y is a dependent. That is X dependent on Y. So it's an example for functional dependency. One attribute dependent on other. The functional dependency is a constraint that determines the relation of one attribute to the other attribute in database management system. Here the one attribute that determines the relationship of the other attribute. So functional dependency helps to maintain the quality of the data in the database. So functional dependency helps us to maintain the quality of the data in the database. It plays a vital role to find the difference between the good and the bad database design. So it plays a vital role to differentiate between the good and the bad database design. The functional dependency is denoted by an arrow mark. So X and Y. Here X is a determinant and Y is a dependent. It is represented by an arrow mark. The functional dependency of X on Y is represented by X arrow mark followed by Y. Example for functional dependency, here we have taken employee table. So employee number, employee name, salary and city. So here employee number is an unique and it acts as a primary key. Here all employee name, salary and city depend on employee number. So it's an example for functional dependency. Next is axioms. In that we have a set of inference rules used to infer all the functional dependency on the relational database. Here we have a set of inference that makes sure to have all the functional dependency on the relational database. Next is minimal cover. In minimal cover, every dependency has a single attribute in its right hand side. So E is a minimal set of dependency and F is equivalent to E. Every dependency in F has a single attribute for its right hand side. We cannot replace any dependency which will be on X side. So F is a dependency and X is a functional dependency of A, where Y is the proper subset of X, and still we have a set of dependency that is equivalent to F. Say for example A So the example for functional dependency, we have taken an example. Here B is dependent on A and C is dependent on B, and all the ABs is dependent on A and AC is dependent on B. As per the definition, all the right hand side should be a single attribute. Now we have to split into single attribute, that is D A, D B and D C. So here the redundancy occurs. Suppose if you remove it and bring back to the minimal cover, it become A Here it says that all the dependency have a single attribute in the right hand side and remove the redundancy from the element that they have given. So it's an example for minimal cover, and AC is to D. So left hand side it should have two attribute, but right hand side it should be single attribute. Next is maximal cover. In maximal cover, every dependency on the left hand side should be a single attribute. Here, the maximal possible of the functional dependency is the number of possible left hand side and the number of possible right hand sides. We are including trivial functional dependency. So here we are including trivial functional dependency, and the number of possible left hand side equal to the number of possible right hand side. Means LHS must be equal to RHS. So there are 4 types of functional dependency: multi-valued dependency, trivial functional dependency, non-trivial functional dependency, and transitive dependency. So these are the types of functional dependency. Next topic is normalization. So normalization means organizing the data in the database and removing the inconsistency, redundancy that will occur while on the relational table. So normalization is the process of organizing the data in the database to avoid data redundancy and insertion anomaly, update anomaly and deletion anomaly. So while organizing the data, these are all the anomalies occurs. So just to remove all the redundancy and inconsistency from the table, so normalization helps us to organize the data in the database. Normalization is used to minimize the redundancy from the relation or the set of relation. So we have a table. In the table, it used to minimize the redundancy while performing some basic operation. It is used to eliminate the undesirable characters like insert, update and deletion anomaly. And it is also used to remove the undesirable character while performing some operation like insert, delete and update. The normalization is used to remove those anomalies from the relational table. So normalization divides the larger table into smaller table and link them using the relation. So we have table that divides the larger table into smaller table by using a join relation. We can link them using relationship. The normal form is used to reduce redundancy from the database table. So this normal form which is used to reduce the redundancy from the database table. Next we have types of normalization. There are 4 types. First normal form, second normal form, third normal form and Boise code normal form. The first one is first normal form. So if you want to say that the table is in the first normal form, there are certain rules we need to follow. The first rule should be it must contain a single or atomic value. There should be no multiple attributes in the table. The first rule is it should only have single valued attribute. In the table, it must contain single valued attribute. The value stored in the table should be of the same domain. Whatever the value stored in the table should be of the same domain. Suppose if you take employee table, it should contain only the details of employee, not the details of department. That is of the same domain. Next, all the columns in the table should have unique names. In the table must have unique names. If and only if all the column contain only atomic values, that is each column can have only one value for each row in the table. Example for the first normal form is employee ID, name, job, department ID and skills. And we have to bring this table into first normal form. So for that we can make skills one table. The first employee ID is 1, Bob, and Bob job is programmer followed by department ID. The skills that we have is C, Perl and Java. that will included as first table. Second employee ID is 2 and the name is Alice and the job is DBA, that is database administrator, and the department ID is 2, and he will get one more table, that is MySQL and PostgreSQL. We can say that the data is in the first normal form. Next is second normal form. Suppose if we want to say that the table is in the second normal form, the table must follow all the rules of the first normal form, and in the second normal form there should be no partial dependency. If you want to say that the table is in the second normal form, it should be in the first normal form and it should not have any partial dependency. So here we have employee code, project ID, employee name and project name. Here the employee name is depend on employee code and project name is depend on project ID. So project IDs depend on employee code as well. It is partially dependent. The key characteristics that make up one or more candidate keys are the primary characteristics. The employee project detail table can be divided into following three tables to eliminate the partial dependency and normalize it into the second normal form. So using this table, we can divide this table into three tables to reduce the partial dependency. So we have employee code and employee name. This is one table, and employee and project code. So project IDs depend on employee code as well. And one more table is project name is depend on project ID. So these three tables says that it remove the partial dependency from the table. We can say that it is in second normal form. Now if you want to say that it should be in the second normal form, it remove all the partial dependency from the table. So splitting the table into three tables. One is employee project detail database into the employee details, project details and employee project tables into three tables. So one is employee detail, project detail and employee project table, and we are able to convert into 2NF. Now the table is in the form of second normal form. As we can see that mentioned, the table added to the same 2NF rules has 1NF rule. It has the same rule what first normal form have, and each non-prime property completely depend on the primary key. So now we can say that the table is in the second normal form. Next is third normal form. Now if you want to say that the table is in the third normal form, that should be in the second normal form and it does not have transitive dependency. Means all the non-prime attributes should depend only on the primary key. That must be in primary key. The attribute that it has, it should depend only on the primary key. So the example for that is the student ID, student name, courses, instructor and instructor office. Here everything must depend on student ID itself, but here in this table the instructor office depend on the instructor. Here we have transitive dependency. Now converting this table into third normal form, first we have the instructor information is repeated for the multiple students taking the same courses. Here the instructor information is repeated for the multiple students who are taking the same courses, and here a partial dependency. The instructor and the instructor office are dependent on the courses. Here the instructor and the instructor office are dependent on the courses and not on the student ID. So if we divide that table into two tables, we get student table and course table. So the student ID, student name and course ID. The course ID and student ID depend only on the student ID. So based on the student ID, we can check the student name followed by the courses that student has chosen. Next is courses table. In course table, we have course ID, courses, instructor and instructor office. Here all the non-prime attributes depend on the primary key. That is courses, instructor and instructor office depend on the course ID. So we can say that the table is in the third normal form. Last one is Boise code normal form. Suppose if we want to say that the table is in the Boise code, it must be in third normal form. It's an extension of third normal form. It's a type of database normalized used to eliminate the redundancy and ensure data integrity. So it must be in third normal form. So every functional dependency XY is a super key. Here X is a super key, and we divide the table into two tables. One is course table and room table. So the course ID, instructor and course office depend on the course ID, and room table, room and instructor. So the instructors depend on room. The course table enforces that each combination of the course ID and instructor determines the name. So in the table, the course ID and the instructor which determines the room. The room table enforces that each room is associated with a specific instructor. So room table enforces that each room associated with a specific instructor. So it's an example for Boise code. Thank you.